So, in today's lesson, we are taking a jump ahead. In our previous lesson, we were talking about using square roots to solve quadratics, but what we come across is there are a sector of square roots that don't have real number solutions. And so, what we're going to do today is we're going to introduce to you the imaginary numbers. And the reason they were created was because equations like x squared plus 1 equals 0 don't have any real number solutions. So mathematicians defined what we call the imaginary numbers to represent those solutions. Um, the imaginary unit, let's see what we got here. The imaginary unit that we call I, right, lowercase I, is defined as I equals the square root of -1. And it's useful when we're working with square roots of negative numbers. So a pure imaginary number is one of the form is written in the form of BI, where B is a real number, could be any real number, and I is the imaginary part. Right, so you'll see them all the time as things like 3i or -42i, right? Where the real number clearly is the number that you see, and I would be the imaginary part. One of your assignments the other day was on simplifying square roots. Now we're going to take a look at simplifying negative square roots. We also had to use square roots to solve these quadratic expressions. And above, we talked about the expression x squared plus 1. And we said that it had no real number solution. And if we look at it, we can see that it has no real number solution, right? We could do what we were supposed to do, right? We could isolate the x squared by subtracting 1 from both sides. And we would get x squared equals -1. And when we went to take the square root of each of these sides, we would have no real number solution. We would get our x equals here, but no number times itself actually equals -1, right? We can go, well, 1 times 1, that's still 1. And we can go -1 times -1, but that's still a positive 1. So what we did is we came up with what we call the imaginary number system. And since the imaginary number system basically tells us that I equals the square root of -1 and that I squared equals -1, right? So we can look at this and we can say without hesitation that if I equals the square root of -1, and we're saying that if we take the square root of x and get x, and we take the square root of -1, we would get x equals I. And when you think about that, it kind of makes sense, right? Because if I said that I have the square root of -1 and I square it, right, I'm going to get whatever is underneath the radical, right? In the same sense, if I have the square root of 4, let's call it the square root of 5, and I square it. That's the same as saying the square root of 5 times the square root of 5, which we know just gives us whatever is under the radical, right? So in that same respect, that if we know that I squared equals -1, which we stated up here, right? I squared equals -1. We know that if I have the square root of -1 and I square it, right, I'm going to get whatever's under the radical, which is -1. And that's how we know that I squared equals -1. I'm not going to get too much further into that because I've explained it more during the lesson in class. And we can look at things like the square root of -5, right? And when we want to evaluate that, we would go, okay, well, that is the square root of -1 times 5, right? And the square root of -1 is just I, so I would write that as plus or minus I. And we can't break down that 5 any further, so it would have to stay there, right? In the same respect, if I have the square root of -25, we know that that is going to be plus or minus 5i, because 5 times 5 equals 25. And we know that that negative in front just means that we have to include the I in it. And we can do that for absolutely anything under the square root. So sort of self-explanatory, right? When we get to that, when we look at it in terms of solving equations, as we were doing the other day, and as you will have to do in this homework, we're going to take problems like x squared plus 81 equals 0. And we're going to have to follow those same steps that we did the other day when we were solving square roots, where we would have to isolate the x squared, right? So that means we're going to solve for x squared. We want x squared to be the only thing on this side of the equal sign. And I'm going to start by undoing everything that's being done to it. Right? And the only thing we have being done to it is 81 being added to it. So we're just going to subtract 81 from both sides. And we're going to get x squared equals -81. And when we want to solve that, right, then we're going to take the square root of both sides. Take square root of both sides. Right? Let's do that in baby blue. So take the square root here, and I'll take the square root here. This we know, x times x equals x squared, so we've got x. But here, we're at a bit of a standstill unless we remember that we can break this up as -1 times 81. And we can pull these out as separate entities, right? X equals, well, what do we know? We've got plus or minus I times the square root of 81. And if we remember that 9 times 9 equals 81, we would know that x equals plus or minus 9i. This is our final answer. It's 2 solutions, right? One is positive 9i and the other is negative 9i. And we can do that forever. Let's look at a more complicated one. What if we have the example 4x squared plus 15 equals -9? We're still going to isolate that x squared. isolate x squared. That means undo everything that is being done to it at the time, right? What's happening first? We have this 15 added to it, so we're going to do the opposite of adding 15 and subtract 15, right? So let's start with that. Negative 15, negative 15. This is going to give me 4x squared equals negative 24. The next thing we've got is we've got 4 multiplied to the x squared. So we are going to do the opposite of multiplication, and we are going to divide both sides by 4. And we will be left with x squared equals negative 6. So we've isolated the x squared. It's the only thing there now. So now we need to take the square root of both sides, right? So let's look at that. Here I'm going to take the square root of x squared, and I'm just going to get x. Now I need to take the square root of negative 6. And when I do that, I know I'm going to get plus or minus something. And in this case, the negative I know comes out as an I. And if you look at 6, if we break it down, 6 is just 2 times 3, and those are prime numbers. So we really can't pull anything out of there. There's no pairs. There's no perfect squares. So that 6 is just going to have to stay underneath the radical. And we can do this forever and ever for multiple problems, but I can't do that with you because I got another little thing to talk about before we get there. And that is multiplying squares. Now, so far I've told you that I squared, right? I times I, which is I squared, equals negative 1, right? And if I talk to you about the powers of I, which you're getting a lengthier lesson on in class today, what we can see is that, well, I just equals itself, right? I to the first power is just I. I squared, we've already discussed, equals negative 1, and we discussed why it does. I to the third is like saying I squared times another I. So negative 1 times I is just negative I. I to the fourth, well, that's like saying negative I times another negative I, right? Which is just like saying negative 1 times negative 1, which is just positive 1. And I'm not going to go into all of them because I'll have another video with that for the extra credit assignment. But I just want you to understand how these i's work together. And if you look at this, this is just itself. This one is technically I times I, right? Which gives us that negative 1. This one is like saying I times I times I. And we know that that equals negative I. This one is the same as saying I times I times I times I, right? And if we look at this, we know I squared is negative 1, and I squared is negative 1. And if we have negative 1 times negative 1, we just get positive 1. And the reason I went through all of this with you is that we need to talk about products of imaginary numbers. Anytime you see the word product, we're talking about multiplication. Right? And so we want to talk about what happens when we multiply these things. So, for example, if I have 4i times 7i, when we first multiply them, let's think about them in terms of if I was just a variable. Think of it like it's x. We would go, well, 4 times 7 is 28. And then that I times I is just I squared. So we'd have 28I squared. But what we know is that I squared equals negative 1. And so we would have 28 times negative 1, which gives us negative 28. What if I had the example, I'm just going to do a bunch of examples here for you to see what they all look like. What if I had negative 4i times 2i times negative 9i? We're going to multiply all of our numbers. We'd have negative 4 times 2 is negative 8. Negative 8 times negative 9 is positive 72. And then we'd have I times I times I, which is like saying I to the third power, right? Well, we know I squared is negative 1, right? And then if we multiply that times another negative, we'd wind up with negative I, which I showed you up above, right? If we had I to the third, we'd wind up with negative I as our total. So we could write this as negative 72i. Here, if we look at this example, and we had 2i cubed times 5i. Well, let's just look at that for a second, right? 2 cubed equals 8. I cubed is just I cubed. We'll keep it that way for now. Times 5 times I, 5i. We'd go 8 times 5 is 40. I cubed times I is I to the fourth power. That's like saying negative 1 times negative 1. I squared times I squared, right? And if you remember correctly, when you come up here, I to the fourth power just equals 1, because negative 1 times negative 1 equals 1. And so this solution would just be 40 times 1, which is just 40. And so when you're dealing with these multiplication problems that you've seen before, you kind of want to know how to break them down. Just for the sake of having more examples to show you, what if I had I rad 3 squared times negative 8i squared. We know that when I apply this square to the I, I'm going to get I squared. When I square anything inside of a radical, I just get that number. So it's going to be times 3. And then we've got times, well, negative 8 squared. Keep in mind, we're squaring the entire thing, the negative and the 8. That's going to be positive 64 times I squared. Right? So we can look at that as 3 times 64, right? I have no idea what 3 times 64 is off the top of my head, but I do have a calculator right in front of me. I should have written that down. Is 192. So we're going to have 192 I squared times I squared is I to the fourth. And if you remember, I to the fourth just equals 1. So it would be 192 times 1, which just equals 192. So I'm giving you lots of examples of to play with this with your homework problems. And there's opportunities for you to do some solving with square roots. You are going to have one that has a fraction, just like the other day, involved in it. Maybe. I can't actually find the homework that I printed. Yes, you will. I'm going to go ahead and alter the homework assignment that goes with this to just take you through 2 through 20 evens only. If you have any questions, please let me know. I was trying to provide you as many examples as I could so that you can refer to it when you are doing your homework if you need to. And if you have any questions, just let me know. I'll talk to you later.